Hi everyone, so today I'll be teaching you guys simultaneous equations, which is my favorite maths topic ever. Alright, so I'm so excited to teach this, so let's go into it. So on the screen here, you have three different puzzles. The first one, which is the easiest, is the top left corner, and the hardest one is the big one on the screen, which is on the right hand side. Now, after I finish explaining what you guys have to do, I'd like you guys to pause this video and then take however long as you need and then unpause it so we'll go through the answers together. So what you need to do is for each of the puzzles, give me the value of each of the animals. So in the easiest one, you know that a lion plus a lion is equal to 10. And you also know that a lion plus a wolf is equal to 11. So pause this video now, try and figure out with whatever method you have to give me the values of those animals. Alright, so from the first puzzle, so the easiest one, you should have found that a lion is equal to 5 and a wolf is equal to 3. In your second puzzle, you should have found that a lion is equal to 2 and a wolf is equal to 9. And in your last one, you should have found that a bear is equal to 17, and I gave the answer bear first because I'm assuming you worked out the bear first because 6 bears is equal to 102, so all you needed to do was go 102 divided by 6. A rabbit is equal to 4, a fox is equal to 1, and an elephant is equal to 11. So, can we solve this one? So if I give you a giraffe plus giraffe plus giraffe equals to 30, could you give me the answer to this? So the answer is yes. What about this one? So you have giraffe plus frog equals to 40. So the answer for this one is no, because they could be any number. So the two puzzles that you see on the screen here are independent from one another, so they don't equal to the same one. So in this second puzzle, a giraffe does not equal to 10. So that's why we can't solve this one, because I could say that the giraffe is worth 20, so the frogs would be 10 each. So 20 plus 10 plus 10 is 40. But I could say also that the giraffe is equal to 38, and the frogs would be equal to 1 each. So the giraffes and frogs can be equal to anything. That's why we can't solve for this puzzle. And what about this one? So I have giraffe plus frog is equal to 5. And I have giraffe plus frog is equal to 7. Now the answer for this is yes. Yes, we can solve it. So why can we solve for the third equation, or third example, or third puzzle, but not the second one? And the reason why is, in the last one, I have giraffe plus frog is equal to 5. Now, once I figure out what the giraffe and frog is equal to, I can check my answer by looking at the second puzzle. So, the giraffe plus frog one. And if the same answer, if I get this answer of 7 with the same answers for the giraffe and frog, that means that my answer is correct. Whereas in the second one, I don't have a second example to back up my answer. So to be able to solve simultaneous equations, we need at least the same number of equations as we have variables. So if I give you two variables, so a giraffe and a frog, I need two equations, so 2 rows before, in order to solve for it. So this means that if there are two variables in the equation, then there should be 2 equations for us to solve. So in this example here, I had lion plus wolf is equal to 11. And in the second equation, I have lion plus wolf is equal to 13. And that's how I was able to solve that, or you guys were able to solve that a lion is equal to 5 and a wolf is equal to 3. Now, how can we write this algebraically? So let's say that the lion is equal to x and the wolf is equal to y. So therefore, where I had lion plus wolf is equal to 11, I can rewrite that as x plus 2y is equal to 11. And then in the second row, I can write 2x plus y is equal to 13. Now, to solve simultaneous equations, there are 3 ways. So when you solved the puzzles for me in the beginning, you probably did it through trial and error. So that's one way to solve for simultaneous equations. Another way is graphically, so graphing them. And then the third way is algebraically, so using either the substitution method or the elimination method. Now, I can't really teach you trial and error, so today we'll be focusing on graphically and then using the substitution method and the elimination method. So we're going to focus my voice on the first easy puzzle, which was lion plus 2 wolf equals to 11, and then 2 lion plus wolf equals to 13. So if I turned that algebraically, I'd have x plus 2y equals to 11 and 2x plus y equals to 13. Now because they are written algebraically, I can graph them on my graphics calculator or graphical tool online. Now, when you're solving it graphically, you must rearrange the equation so that y is a subject. So y equals to something, etc. So these two equations on the screen that you see, it's not y as a subject, so you can rearrange it. So therefore, x plus 2y equals to 11 becomes y equals 11 take x divided by 2. And then for my equation 2x plus y equals 13, it becomes y equals 13 take 2x. Now from there, you can pop it into your graph and then solve it graphically. Alright, so in order to solve for graphically, so how can I find x and y based off just two lines that I graphed? So what you need to do is graph them on the same plane. So here I graphed the two equations on the same axes, and you could see that they intersect one another. So from the first puzzle, you know that a lion is equal to 5 and a wolf is equal to 3. And if you look on the screen here, where they intersect, so where they cross over, is at the point 5, 3. So when x is equal to 5 and when y is equal to 3, that's when they intersect. So that's how you find your answer graphically. Now, if you don't have a graphics calculator, I've put on Daymap an emulator, which is just an electrical or electronic version of a graphics calculator. And I'm going to go through how to work it out, how to actually pop in all those details onto a graphics calculator. Alright, so this is how you will graph your equations on a graphics calculator or emulator. So your first step is to press menu, and then you can either press your down arrow key or the number 5 to go to graph. From there you press EXE or enter. Alright, so now what you see on the screen here is multiple rows where y is the subject. So that's why I said to you before, it's very important that you rearrange the equation so that it's equal to y. So the first one we have is y is equal to 11 take x divided by 2. So for students using the emulator, all you need to do is just type it normally, so you use the X letter on your screen. And for the students at home, you will just be pressing this, not the students at home, for the students using an actual graphics calculator, you just press this button here to get your x. So that was the first equation. And then the second one was y equals 13 take 2x. So 13 take 2x. And then you press EXE or the enter button. So now that you have your two equations, you press draw. And then if you look here, I can barely see my graphs on the screen. So in order to change it so that I can see it, you press view window or F3. Now this is the same for both the emulator and the graphics calculator. So I press F3. And that will take you to a view window where it shows you what your x-axis is showing and your y-axis is showing. So right now it's showing from negative 6.3 to 6.3 for the x-axis, and for the y-axis it's showing negative 3.1 to 3.1. Now the standard version of it is if you press this STD here, F3, it will be negative 10 to 10 for both of the axes, and then you just press execute EXE and then draw, and it will have it as a center. If you want it to be furthermore or like more zoomed in to the intersection point here, you can just press V window and then write however you want for the range. But I'm just going to leave it as this because I can see the intersection here. Now to find out what this value is, all you need to do is press F5 and then where it says ISCT, which is intersect, you press it again. See, so it will tell you now that x is equal to 5 and y is equal to 3. And if you would like to graph other equations, just press exit and then delete button. And then type in your new ones. This is what I like you guys to write down. So a set of linear simultaneous equations can have either 1, 0, or infinitely many solutions. So if you look on your screen here, when two of the equations intersect each other, there's one solution, so where they intersect. And then if you graph your equations and they both never intersect each other, so they're parallel, so parallel means just going the same direction and never crossing, then there's no solution, so you won't be able to have an x and y value. And when you graph your equations and they are on top of each other, then you will have infinitely many solutions. So x could be 5, y could be 7, and then x could be 2, y could be 19, or etc. Because they're always on top of each other. There will be many x's and many y values. So the second method is solution by substitution. So the method of solution by substitution is used when at least one equation is given with either x or y as a subject of the formula. So remember, being a subject of a formula or equation means x equals blah 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 or y equals blah blah blah. So the x or the y letter is by itself. So when we have that, we can substitute an expression for this variable into the other equation. Alright, so let's go through an example together so you can understand it a bit more. So solve simultaneously by elimination 4x plus 3y equals to 2 and x take 3y equals to 8. So here are my two equations. So remember I said they need to have the same size but opposite in sign. So if you look here between 4x and x and then 3y and negative 3y, you can see that this here has the same size. So they're both 3y. And then they have opposite sign though, so one's a positive and one's a negative. Now because that's the case here, we can solve by elimination. So what that means is your goal is to have either the x's or the y's cancel out. So now that will be the case, so have 4x plus x, and that's equal to 5x, and then 3y take 3y, that's 0, and then 2 plus 8 is 10. And now you just have a normal equation, so 5x equals to 10, so therefore x is equal to 10 divided by 5 because I want to know what x is by itself, and that's just equal to 2. Now from there, you just substitute in one of the equations, so either 4x plus 3y equals to 2 or x take 3y equals to 8 to find out what y is. So I know that x is equal to 2, so I go 2 take 3y equals to 8. And then I want to move the 2 to the right hand side, so I'll have negative 3y is equal to 6, and therefore y is equal to negative 2. And remember, if you want to check if your x and y values are correct, just plug them into one of the equations. Alright, so here's another example. So 3x plus 2y is equal to 7, and 2x take 5y is equal to 11. There you go. So what you can see here is none of these terms have the same size. So, so 3x and 2x, they're not the same. 2y and negative 5y, they're not the same. So what you need to do is try to make them the same size. So you can pick either the x's or the y's to multiply by a number. So I'm just going to pick the x's. So I have 3x and 2x. Now I need to find a number where I can times them so they both have the same size. So all you need to do is find the lowest common denominator. So to do that, all you need to do is list out the multiples of 3 and the multiples of 2. So for example, the multiples of 3 are 3, 6, 9, 12, 15, etc. And the multiples of 2 are 2, 4, 6, 8, 10, etc. So when I listed out those before, the common one, or the first number that appeared in both, was 6. So I need to somehow make these two coefficients of x equal to 6. So in the first equation, I can multiply everything by 2, and that will give me 6x, 4y, and 14. And then in the second equation, I can multiply everything by negative 3. And the reason why I multiply by negative is, remember, they have to have the same size, but different in sign, opposite sign. So if I multiply the first equation by 2, I'll have 6x plus 4y equals to 14. And then in the second equation, if I multiply everything by negative 3, I'll have negative 6x plus 15y equals to negative 33. So now that both of them are the same size but are opposite in sign, I can now add them. So that will eliminate, and then the coefficients of x will eliminate, and then I'll have 19y is equal to negative 19, because 14 take 33 is negative 19. So therefore my y is equal to negative 1. And then what I did before, I'll do again now. So I substitute my value of x into one of the equations. So I pick the last one again. So I'll have I substitute my y. So I have 2x take 5 times negative 1, because I know that y is equal to negative 1, and that's equal to 11. So then 2x plus 5 is equal to 11, and then I move the 5 to the other side. So I have 2x is equal to 6, and therefore x is equal to 3. Now I'm going to go through one more example. So I have 7x plus 3y is equal to 5, and I have 5x take 6y is equal to 9. Alright, so again, these don't have the same size, but they have opposite in sign. So to make it easier, I'm just going to do y instead now. So I have 3y and I have negative 6y. So remember what I said before, you don't need to multiply numbers to both of the equations, you can just do it to one. So in this case here, I can just multiply the first equation by 2 in order to get the same size. So then I'd have 14x plus 6y is equal to 10. And then this is my second equation here. So 5x takes 6y is equal to 9. So then 14x plus 5x is equal to 19x. And then the y's will eliminate each other. And that's equal to 19. So x is equal to 1. And then again, I'll substitute. So I just pick the last one again. So 5 times 1 takes 6y is equal to 9. So therefore 5 takes 6y is equal to 9. And therefore negative 6y is equal to 4. And therefore y is equal to negative 2 over 3. So remember, if you're not sure about your answer, because usually when kids see fractions, they'll freak out and think they got the wrong answer. So remember, just substitute that into your calculator or into your equation to see if you're on the right track or not. So here are 3 examples that I'd like you guys to do. So pause the screen again, take however long you need, and then once you're done, unpause the video to go through the answers. Alright, so for the first one, you should have had x is equal to negative 3 and y is equal to 1. In the second one, so they were fractions, so you should have had x is equal to 8 over 5 and y is equal to 22 over 5. And then in your last one, you should have had x is equal to negative 13 over 5 and y is equal to 29 over 5. My voice. Alright, so here are the exercise questions that I'd like you guys to complete. So exercise 4.6 from page 206, and the questions are 1, 2, 3, 4, 9, 10, 11, 12, 14, 16, and all of them are aces.